What you are about to see is the world's finest thermal desorber. Built tough for today's remediation projects, and together with Enviro Klean's exceptional service, the KM4 can deliver outstanding results when meeting your most challenging environmental requirements. Introducing Enviro Klean's thermal desorber, the KM4. Portable thermal desorption technology developed over 20 years for today's remediation projects. The KM4 is cutting-edge technology in thermal desorption. There are many benefits to this machine: portability, automatic operations, quality engineering, fuel efficiency, and environmental responsibility. First, let's take a look at the portability design. The entire thermal system sits on one trailer and operates with a two-man crew. There are two primary systems on the trailer: the material feed and discharge, and the air supply and exhaust. Let's go look at the material side first. The hopper sits on top of the rear of the machine and receives the material. It uses ultrasonic detection to maintain the soil seal and prevent overfilling the unit. Material flows from the bottom of the hopper into the preheater. This device warms, dries, and mixes the material and has a residence time of about 2 minutes before entering the processor. In the processor, the material is conveyed through a series of chambers using a patented soil curtain design to continue the drying and mixing process, so even the smallest particles of material are exposed for treatment. The lower processor chamber conveys material into the pug mill, which rehydrates it for cooling and dust control. Clean material drops from the pug mill onto a stacking conveyor, where it is stockpiled and often reused for backfill at the same site. The air side of this system is a bit more complex and flows from bottom to top, moving in a counter-flow direction to the material. The KM4 is an indirect thermal system, and the burner flame does not contact the material. Heated air travels upward through the individual processor chambers, where it vaporizes the water content, heats the material, and volatilizes the hydrocarbons at their boiling point. The hot air leaves the processor and enters the preheater, where it continues to travel in a counterflow direction with the material. The air mixture, which is now composed of hot gas, water vapor, volatilized hydrocarbons, and particulate, then enters the thermal oxidizer, where it is further heated to oxidize the hydrocarbons. After leaving the thermal oxidizer, the airstream enters the preheater lower chamber and flows through a series of ducts to the front of the machine. The heat exchanger sits on the front of the machine, and since the oxidizer typically runs at 800 C, it cools the air rapidly to a temperature appropriate for the baghouse, which is about 200 C. The baghouse is on the back of the machine and filters the now hydrocarbon-free particulate from the airstream. Since the air is now cleaned of hydrocarbons and particulate, it is ready to re-enter the atmosphere. Automatic operations. Controlling the KM4 is easier than you might think with our user-friendly Siemens interface. All of the components on this trailer are wired and centrally located in this electrical cabinet. The wires are numbered and referenced to a terminal on a machine component. In turn, all of these connections are cabled to the control house. The KM4 has two computer screens. One of them is used to graphically display all the operating data. Here you will see the hopper. Then there are the screw conveyors, thermal oxidizer, processor, sensors, and so on. Each image is complete with all the relevant production data for that component. For example, the heat exchanger shows the air temperatures to the baghouse and to the burners. The color-coded components on screen gives the operator the ability to monitor all systems simultaneously. Let's look at the other control screen. Here, the operator can input the system parameters either before starting the machine or even when it's in production. Once the parameters are set, the machine runs automatically. This is a Siemens system, which is widely recognized as the world's best for this purpose. Also in the control house are the variable frequency drives, which manage the major components of the machine. They operate the KM4 while optimizing maximum volume of material cleaned in the minimum time using the least amount of energy. Now, amazingly, a single thermocouple located at the material discharge end controls the mechanical system you see on the trailer. Hydrocarbons have different boiling points, and depending on the cleanup criteria for a remediation site, the soil is heated to a predetermined temperature to properly volatilize the hydrocarbons before the soil is certified as clean. The operator sets this temperature, and the computer system automatically adjusts the burners and other components to maintain this temperature. Lastly, the feed system is also automatically controlled and delivers the right amount of material to the machine when needed. It has a trommel that screens and mixes the material before it's conveyed to the hopper on top of the machine. In total, there are more than 30 drives and over 20 sensors that control all aspects of operating the KM4 and makes it possible for a two-man crew to manage everything. Quality engineering. The fabricated components on the KM4 are either patented or proprietary and are custom built for strength, safety, and reliability. The KM4 is capable of 24/7 operations. You can run it indefinitely without shutting down for service. The bearings need occasional greasing, but up to temperature, you can run thousands of tons of material without stopping. Extra care has been taken to make servicing easy. All the parts are accessible and can quickly be examined and adjusted when required. The patented processor design is the heart of this machine. It's a highly efficient furnace that supplies heat to the interconnected screw conveyors and troughs. If any one of them should jam, it automatically cycles back and forth and clears the jam within a few seconds. Similarly, the preheater is constructed so that its screw conveyors can run constantly without problem. Both of these components are easily serviced from the access doors on the front of the processor and on top of the preheater. Most of the KM4 is constructed from stainless steel, which is rust and corrosion resistant and can take higher temperatures than mild steel. Inside the processor and thermal oxidizer, temperatures can exceed 1000 C, and the KM4 uses appropriate stainless steel grades for this purpose, as much as 12 mm stainless when necessary for strength and 310 stainless in hot locations. We see no value in compromising quality and strength, and this equipment is constructed to operate indefinitely under the most extreme conditions. The SEW Euro drives and gearboxes are just an example of the effort and great lengths in which quality and dependability have been brought to the operators and their owners. Even the trailer for the KM4 is extra strong and custom designed for this application. Fuel efficiency. The fuel connections are located at the back of the machine with a separate connection for both gas and oil. The gas connection can be used for natural gas or even methane. Multi-fuel capability helps to minimize varying fuel and operating costs. All the fuel line controls are mounted in a common area in the center of the trailer and relays fuel consumption data back to the control house. Each KM4 has the piping, regulators, valves, and meters all custom installed and rigorously tested for safety and performance. At the end of the fuel train is a multi-fuel burner that mixes the fuel with combustion air to supply heat for the furnace. The furnaces are lined with a ceramic refractory. It's very lightweight, and although the temperatures inside the processor and oxidizer can be over 1000 C, the ceramic is such a good insulator that Mark can touch the processor with his skin without any danger of burning his hand. The single largest operating cost for thermal desorbers is the fuel. The combustion engineers who designed this machine make it possible for the KM4 to achieve a 50% or greater fuel reduction compared with competing equipment. All of us are working hard to do our part to clean the environment, but we feel it's important to point out the financial advantages of the KM4. For the purposes of this discussion, let's assume that a thermal desorber remediates 100,000 tons of material in a year. A rotary kiln may use 40 liters of fuel per ton, whereas the KM4 would use 20 liters. the fuel saving would be 2 million liters or more. This means that the KM4 can pay for itself in a year or two, especially when the savings associated with a smaller operating crew and compact size are included. Since the KM4's airstream is about half the size of a rotary kiln with the same throughput, the components like the baghouse, heat exchanger, and thermal oxidizer are also half the size, making them easier and less costly to service if necessary. Finally, let's take a brief look at some ways the KM4 is engineered to do its part to protect our valuable environment. The portability feature makes it much easier and faster to permit than a fixed plant. When thermal remediation is possible, it eliminates the costs, liabilities, and hazards associated with landfilling. The small size of the equipment, relative to the throughput, results in significantly lower air emissions that easily meets or exceeds the strictest air emission standards. And for safety, the KM4's electrical and fuel systems are rigorously CSA certified and comply with UL regulations in the States and CE certification in Europe as well. The KM4 is engineered with a thermal oxidizer before the baghouse, which is sometimes referred to as a hot plant. When the oxidizer is first, it immediately destroys hydrocarbons when they leave the processor and before they get to the baghouse to avoid condensing problems. The KM4's thermal oxidizer is custom designed to provide operators with up to 6/9 destruction efficiency for hydrocarbons and provides for a 2-second residence time. The preheater sits just above the thermal oxidizer, capturing the heat before it travels to the heat exchanger. The compact design of the KM4 has allowed the engineers to recover considerable free energy to heat the incoming soil. We have chosen an air-to-air heat exchange method to cool the gas before it enters the baghouse because it's trouble-free and eliminates the danger of fines clogging the system. The combustion air makes its way to the stack and re-enters the atmosphere clean, thanks to the KM4's sophisticated air control system. Air emissions are measured at the stack, and the KM4 can be fitted with an onboard emissions monitor that logs the data in the control house. In addition to the benefits of portability, automatic operations, quality engineering, fuel efficiency, and environmental responsibility, the KM4 offers the certification security of electrical CSA, UL, CE, environmental EPA air emission standards, HAZOP safety review, and gas inspection certificates. The KM4 is truly the best choice in remediation. Together, these men and other technical specialists have poured countless hours into the engineering and have pooled their 100-odd years of engineering and practical field experience to help produce a truly unique machine.